Guys, I have a question from moment to solve. The question is asking determine the moment of the force about point O. So this is the point O, so we have to find the total moment. First of all, we have to find this, since this one is not acting vertically or horizontally, I have to find the vertical and horizontal force to find the total moment. Let's calculate that one. So let's first of all I'm going to draw the free body diagram of the same thing. It's going to be like this, 5 meter, and this is 2 meter, and the force is acting like this direction, 100 newton, and we have a horizontal force right here and a vertical force right here. We have to find it. Let's say horizontal force is F1 and vertical force is F2. So if I want to find horizontal force, we have this two distance. So whenever you see like 4, it's going to be whenever you see something in x-axis, it's adjacent, and if you see something in the y-axis, it's going to be the opposite. So in order to find the horizontal component, I have to use cos theta. So it's going to be 100 times cos theta. Cos theta is going to be adjacent over hypotenuse. Adjacent is 4 and hypotenuse is 5. So it's going to be 100 times 4 over 5, which is going to be 80 newton. And the next one is going to be F2. F2 is going to be this force times sine theta, because it's acting vertically, so I have to find the vertical force, therefore it's sine theta. So 100 times 3 over 5. 100 times 3 over 5 is 300 over 5, 60 newton. Since we have the force right here, now we have to find the total moment. In order to find the total moment, I have to multiply this by distance. Let's see. So first of all, we have to make a sample diagram. So this is the origin O, right? And this is I'm putting a dot line to make a square to show exactly where it's gonna turn around, because we have to know that then only we can put positive or negative. We have to know it's whether it is turning clockwise or counterclockwise. So for example, if you imagine if this was, let's say this was acting this side, right? So if something pull this word, which side it will go? It will turn clockwise, right? It will turn clockwise. And if some force act from pull this object down, what's going to happen? It's going to go down, and it's also clockwise. So if something is clockwise, we put the negative sign for the clockwise. So first of all, we have the 80 newton. That's horizontal. So you have to find. So whenever you apply a force, you have to find the distance perpendicular to that. For example, for F1, what is the perpendicular distance? 2 meter is the perpendicular, right? So I have to multiply this one by 2 meter, and this is going to be negative because it's clockwise, and minus this one pulling down, and it's also clockwise. That's why I put the negative sign here. And this is I have already found the vertical force. It's going to be 60 newton. Then you have to find the perpendicular distance. Is going to be, if this is vertical, this is the perpendicular distance, 5 meter, right? So I have to multiply this one by 5 meter. 60 times 5, and this is going to be my final answer, minus 160 minus 300. So the final answer is going to be minus 460 newton meter, and this is clockwise. But if you want to put the sign clockwise, you have to get rid of the negative, because you can't put both. If you put negative, you don't have to put the sign, but if you put the sign, you shouldn't put the negative sign. So you can write in both way. I can write 100 minus 460 newton meter, or clockwise 460 newton meter. This is my final answer. I hope you guys like this video. See you next time.